So this video is going to continue chapter 11 of geometry. It's going to cover 11.3 through 11.5, and by the end of this video you should know how to calculate volume. So volume is the measure of the amount of space contained in a solid. And we measure it in cubic units, so that's going to be, for example, like centimeters cubed or inches cubed. So this is the prism-cylinder volume conjecture, which states that if B is the area of the base of a prism or cylinder, and h is the height of the solid, then the formula for the volume is V equals B times h. So essentially, if you have, for example, a cylinder, and you know that the area of the circle here is going to be B, and you know that this length here, the height, if you have a right cylinder that is, otherwise if you get the height, is h, then the volume is going to be the area here. So this is an area and this is a height. This is a length. So essentially, if you break it all the way down, it's going to be, for a cylinder, it's going to be pi r squared to find the area of the base times the height. And for another prism, for example, a rectangular prism, it's going to be the base times height of the base, and then times the height here. So you're multiplying three different values, but it can be simplified to just the area of the base times the height. So if you're given, for example, a cylinder with radius, and you're given that the radius equals 5 and that the height equals 10, then we can use our formula. So we know that V equals base times height, and we know that base, the area of the base, is going to be pi r squared. So we can find that. So base equals pi times 5 squared. So that's going to be 25 pi, and then times the height of 10, you're going to end up with 250 pi, and that's going to be units cubed. So now we have the pyramid cone volume conjecture. It's the same premise, but a little different. So if B is the area of the base of a pyramid or cone, and h is the height of the solid, then the formula for the volume is V equals B times h divided by 3. So essentially, since we have a cone, it's going to be different from, for example, a cylinder, in that the volume obviously is missing all this empty space here, and it turns out to be 1/3 of the area of the volume of a cylinder that has the same base area and height. So if we're given the following figure, it's a triangular pyramid. So we can see that we have the height here equals 7, and then we have a side here which equals 6. And this might not seem like we have all the information we need, but it's actually pretty easy to get. So we can see that all these angles are equal, which means this is an equilateral triangle. So all of these sides are going to be 6. And we can actually use what we learned in a previous chapter about 30, 60, 90 triangles to find this length, which is going to be the height of the triangle that we need to find the area of the base. So this line is going to divide this in half and be a perpendicular line, creating a right triangle, and not just a right triangle, but a 30, 60, 90 right triangle. So then this is going to be 3, this length right here, and we know that if the shortest side is x, then the longer leg is going to be root 3x. So if that's 3, x is 3, then this is going to be 3 root 3. So then we can multiply out to find the area, which is going to be base times height over 2, so we can plug in our values. So 3 times 3 root 3 over 2 is going to give us 9 root 3 over 2 as our area, and then we can plug that into our volume equation, which is going to be b times h over 3. And so we have 9 root 3 over 2 times 7 over 3, and your best bet is plugging that into your calculator, and you're going to end up with 18.19, and that's going to be units cubed.